Hi everyone, and welcome to another episode of Let's Talk Risk with Dr. Naveen Agarwal. Each week, we talk about a topic related to risk management of medical devices in a very casual and informal way. This is not a webinar or lecture. Rather, our goal is to talk about key topics and challenges in a very informal way and share best practices. I'm your host, Naveen Agarwal, and I'm the principal and founder at Achieve, where my personal mission is to help you achieve success in risk management. Hi, everyone, and welcome once again to our weekly Let's Talk Risk conversation. So excited to meet with you once again, and we're going to have an exciting conversation today with my guest, Shannon Hosty. We're going to talk about human factors aspects of AI ML devices. Now, Shannon is someone I have admired for a long time, and I followed her insights and updates on LinkedIn, and it is so personally exciting to me to have this conversation with her. I hope you enjoy it. But guys, remember, you also have an opportunity to participate and share your perspectives and insights. This is not a webinar. This is not a lecture. We are not here for just a simple one-way Q&A type of a conversation. I invite you to take part in this. So we will open the floor in about 10-15 minutes or so. But before we go further, Shannon, first of all, thank you again for joining me. How are you doing today?
I'm doing great. Thank you for having me.
Wonderful. Shannon, so why don't we start by just having you briefly introduce yourself to our audience today?
Sure. I'm Shannon Hosty, and I've worked in medical devices and combination products for almost 30 years at this point. And earlier in my career, I started seeing field issues on devices, couldn't understand why they were happening, turned out to be human factors issues. In my specific case, people were lubricating their insulin pens with motor oil and butter. And I was trying to understand why they would do that. And I wasn't sure how to manage risks associated with that. So I ended up studying in graduate school cognitive systems engineering. And that is all about how people in technology work together or can fail to work together. A lot of work in nuclear, aviation, automotive, research that goes into that, and then applying that to medical. So that's what I've done with my career. And I had an opportunity to lead the human factors team at the FDA as well. And now I've stepped out and I'm doing a little consulting through Chymonex and but mostly teaching and working with Pathway for Patient Health on quality science initiatives and case for quality initiatives.
Thank you, Shannon. So exciting to hear about your extensive background and experience in this area. And, when it comes to human factors, that itself is sort of an evolving field in our medical space. We are still learning this, applying this, and now combine AI ML with this. So help us just understand the whole context here. AI ML, you were discussing with me that it's like an automation. So where does human factors stand in terms of automation and how it has been applied in other industries?
Yeah, absolutely. So from the human factors perspective, when you're thinking about potential hazards that can arise based on people interacting with AI, and when I'm saying this, I'm mostly thinking about AI in devices. You're going to have similar questions, though, if you're using AI in, say, quality system tools. But as I think about human interaction with AI, I think about it from the standpoint of what we would call in our space automation. And so a quick way to think through this, I'll talk through quickly the levels of automation and why I'm thinking about this as it applies to AI. I might be giving some medical examples and some automotive examples just for context. So when I think through the levels of automation this is human interacting with the technology and that technology providing automation. So level 0 and 1 is little to no automation. So it may provide some assistance. So in this case, the one example, medical, might be if I am recording transcripts from my interaction with my patient, and that is just recording it and capturing it, right? It's not doing much with it, but it is converting it to text. An automotive example would be like a lane assist or adaptive cruise control, right? So this is very minimal automation. Next level 2, would be more like a shadow mode or a passive support automation. So this might be crash avoidance in the automotive world. It might be taking that transcript and summarizing it for me, right? So it's a little bit of the next level of support, but it's not making any decisions, pointing any directions. It's compiling and acting in a very expected way. When you're imagining this, you can imagine two cross curves, right? You have the curve of human involvement in a task, and it starts off high at level 0. It's all human, and it tailors down as we go up to the levels of automation. At the same time, the level of automation is ramping up, right? So right in the middle, you have kind of this AI assisted. So it's really the human and the AI, or the automation working as a team. So this could be like a clinical decision support, where you have AI that's crawling through your EHR and identifying that are at the next 24 hours and notifying the clinicians so that they can intervene. Another example might be imaging, AI that's looking at imaging and detecting patterns and then alerting radiologists or clinicians. The opposite could be, say, navigated surgery, where the clinician is selecting a target, but the actual automation is executing that work, right? So that's level 3. Level 4 is a partial is more of the automation is doing a lot, but the human's watching. So when you think about physiological closed loop control systems, like an artificial pancreas, that would be like a level 4. That human needs to be able to intervene if anything's going wrong. And then full automation is where the human's out of the loop. So we're not really there on anything in medical. But as we think about this, there are level 4 in particular I want to talk about. There's a lot of risks at level 4.
Yeah.
There's a lot of risks at level 3 too, but at level 4, that human needs to intervene. And as the automation increases, there's a lot of loss of situational awareness and complacency, right? If it keeps working consistently, when something goes wrong, I'm not paying enough attention to intervene.
Yeah.
Overtrust, those kind of things happen. And so those introduce new hazards that need to be considered and evaluated.
Awesome. What a great overview, Shannon. Thank you for putting this in perspective. And guys, if you're just joining now, my guest is Shannon Hosty, and we're talking about human factors aspects of AI ML devices. So Shannon, we know that FDA has cleared close to 1,000 AI ML devices. In this scale that you have shared with us, where would you place most of these devices right now?
Right now, I think, like clinical decision support largely falls into, say, level 3, level 2 to level 3, somewhere in that ballpark. Mm-hmm. And so when you have risks, there's 2 guidance documents I want to point folks to in this space. One is clinical decision support guidance. And in that guidance, they're talking about, it's actually more about how to decide if it's a medical device or not. But in the 4th tenet that they discuss, they're talking about how does the HCP know when to trust that data? Do they know what went into it, right? So it's a little bit around the transparency or the explainability of those models. And so I think that guidance paints a good picture of some of the human factors, risks, expectations of the FDA. Another one that I think is really good that may not be on the radar of AI/ML folks is the physiological closed-loop control system guidance. Mm-hmm. And that one has an excellent walkthrough, in my opinion, of use-related hazards. I really like the way this guidance talks about risk. I think it uses terminology and on point as it talks through that. And it explores some of the potential hazards associated with automation, but automation isn't just physiological closed-loop control systems. Mm-hmm. AI is, a form of automation. So I think that guidance itself also provides some good information.
Got you. And I think you have shared those links with me. So guys, for everybody's reference, I'm going to post those links in the comments section on this event page so you can review them as well. So Shannon, where I have reviewed kind of recent AI ML-based device clearances from FDA, it seems to me that a lot of them are targeted towards providing assistance in the diagnosis of some difficult condition, but not as a diagnostic tool, but as an aid in diagnosis. Am I understanding correctly the state of affairs today? We are not there at level 4 or 5 at all, right? Based on what you described.
No, I think there are some things that are approaching level 4, but I agree. The most of what I'm seeing is that support type tool, the assistant clinical decision support type work, things along those lines. Mm-hmm. And what I'm also seeing, again, coming in from the human factors perspective, and specifically talking about these hazards that I'm bringing up today, is that is actually one area where I'm seeing the FDA, CDRH specifically, be much more consistent in asking for the human factors data because of the risks associated with, with the user needing to understand when and when not to trust that automation and how to make decisions based on it. And so what I'm even seeing is a lot of these products are going through de novo.
Yeah.
And what's happening is human factors considerations are specifically being called out as special controls.
You are right.
Within those. So when they're identified and codified.
Yeah. Recently, I did a case study on Apple's hearing aid function de novo. Mm-hmm. And you are absolutely right. They were required to do a human factors study. In fact, more than one. And the special controls do require human factors. So great, Shannon, this is a great segue because I wanted to ask you, what kind of questions does FDA ask you when you go in there with like your proposed submission of AI ML devices from a human factors point of view? Can you share a couple of key questions or concerns that FDA shares with you?
Yeah, and I can even, in my experience when I was at the FDA, I did a lot of work on the artificial pancreas reviews. And a lot of the questions there were, as, you may not have full explainability of an algorithm, an AI algorithm, right? We may not be able to make that fully transparent, but we need to make sure that the user's mental model is correct so that they know what's going into it and they know when it's operating kind of at the brittle edge of what it can do. So that could be things where you're trying to understand what information is going into for the clinical decision support to make a recommendation, and that does the clinician understand that? And if something's missing, is the product making that clear so that the clinician can decide, oh, hey, this of these 15 factors that are going into this decision, 6 of them are missing, and how important are those 6? Sometimes they matter, sometimes they don't, right? It's the lowest 6 or it's the highest 6, right? And so making sure that the clinician understands the kind of that transparency. I saw a good breakdown of transparency that talked through, data transparency about what's going into it, algorithm transparency about just kind of that mental model or logic, performance transparency about accuracy, limitations, and clinical transparency about making decisions based on that information. So I think just thinking through and making sure that those considerations are addressed in the risk file, are evaluated, and then appropriately mitigated and evaluated, whether it's through human factors testing or other NIST standards and other things that provide guidance.
And if I understand correctly, I think FDA is really particular about what you disclose in your labeling and how much you disclose, how you say it. Is that a correct understanding?
Yes. Yeah. No, but it's still, especially in medical device, it's still a little bit choose your own adventure, right? We're still defining.
Yes.
We don't have in pharmaceuticals, it's very, the rails are up about what information is being presented and where and all of that.
Because my follow-up question on that was, this is such a new field, an evolving field. Would FDA also require or mandate some kind of training to users in addition to labeling? Is that coming up on your radar or not yet?
Usually where I see that is when the company themselves will identify training as a mitigation.
Okay.
And identify whether it's required or not. So where that comes in is if you're identifying training is helpful, but you're not going to require it, and people may do it or may not do it, in that case, when you come to human factors evaluations, you need to evaluate it potentially without training, right? If you're not going to make sure that's going to happen. So.
Gotcha. Great. So guys, I'm going to start inviting you to join this conversation, and please don't hold back. Please participate, share your perspective, your insights, or a question you might have. So Shannon, while we wait for folks to join us, one of the favorite things that I would like to learn about is reasonably foreseeable misuse. And when it comes to AI, ML, one example that comes immediately to mind, and I've seen that in many de novos, that one of the risks is the healthcare practitioner or the user over-relying on the output, right? I think this is pretty reasonable. I think this is pretty foreseeable. Do you have any insights on how we should address that in our human factor studies?
Yeah, it's absolutely a concern. It's one of the major hazards that are identified just in the decades of automation research. But it's also brought up by the FDA in that PCLC guidance that I mentioned. So they actually explicitly talk about that and refer to that you may need to be monitoring for that in, say, your clinical studies where you're having people do repeated uses and starting to monitor or probe down for that. Simulated use typically is one-time use when you talk about standard formative human factor or summative human factors testing. That's actually one of the, in my opinion, weaknesses of it. But I think clinical studies could provide a good opportunity for that to continue to monitor for that.
Wonderful. Great. So it's good to see Phil, Steve, and Raphael. You have joined us. Phil, you are first. Please unmute your mic and share what you have in mind.
Thank you, Naveen. Hello, Shannon. Long time no talk. So did a little bit of work in the past with a manufacturer that is at RSNA, and they're doing an image AI-guided technology that I can't quite mention, but it does help with HCPs to look for areas of interest, and generally cancerous areas of interest, right? And in your experience, do you have a high-level list of, to your point that humans can sometimes become comfortable with, just letting the AI do its part, but not putting too much trust in it, right? What are some maybe high-level items that you would call out as mitigations to help to mitigate humans from being too comfortable with AI?
Yeah, I think that's part of the challenge, and I think exciting part of the UI design. So as you're thinking about that, how do you design it meaningfully to keep the humans involved to the right level? Right, because we're trying to make things easier, more accurate, more consistent, I think, with AI decision making. But how do we also keep the human plugged into that so that we don't have skill degradation or over-reliance, things like that. So I think that's really part of that UI design, and it's going to depend on the situation and the users. So I don't have
but definitely
one, but I think it has to be deliberate, I guess, is my point.
And essentially, I think when the consequences are particularly serious, it would be a concern upfront. So, guys, I would request you please to keep your microphones muted. We are hearing a lot of background noise. So I want to continue moving, guys. Steve, please go ahead and unmute your mic and share what you have in mind. Go ahead, please.
Yeah, hi, Naveen. Hi, Shannon. I have a question about earlier this week, FDA released its guidance document on AIML software functions for PCCPs. I've downloaded it. I just took a quick glance at it. Haven't really had a chance to dive in. But Shannon, I was wondering if you've had a chance to look it over yet and if there were any aha moments that you picked out.
Yeah, no, I unfortunately have not had a chance to unpack that one yet. But I look forward to further discussions. I'm sure it's going to be discussed quite a bit and maybe here in the future. So I need to unpack that and take a look. I think a lot of that is a little bit, I'm going to speculate. A lot of the discussions I've had around the PCCP is more around kind of the regulatory pathway. And, kind of defining what you're going to do and how you're going to do it. So I feel like the risk that we're talking about here is kind of the level below that how do we think about the risk of it? We're in the details. How do we control that risk? To me, feels more like that PCCP level. So I'm looking forward to it.
Well, so I think that's a good point, Shannon. I just want everybody to know that a draft guidance was also issued by FDA several months ago. I think there was a lot of discussion. And in fact, I do have a podcast on Let's Talk Risk in my conversation with Yu Zhao, who has already done a couple of submissions, PCCP submissions. So we'll be having more conversations about it. But it's definitely a very important point, especially for AI/ML, because they are supposed to be self-learning applications, right? So a lot of concerns.
Absolutely.
So more to come on that. Thank you, Steve, for bringing that up. Rafael, you are next. Thank you for your patience. Please unmute your mic and share what you have in mind.
Hi, Naveen. Good to be here. And awesome talk so far, Shannon. You mentioned over-reliance on the automation, the artificial intelligence. This actually came up in a risk assessment I was conducting about a year ago for a company that did diagnostic imaging. And their whole use case was they're trying to help radiologists out who basically numb out from reading it all day. And they might miss something that's potentially a big problem. And they hadn't considered that the radiologists, because they were so numbed out from effectively grading papers all day, would become overly reliant on the artificial intelligence, even in an assistive mode, where the radiologist still has to make the call, but they're given a lot of clues. And that was something they hadn't even considered. A whole bunch of cuss words flew, and they updated the risk model. So I thought, based on your comment about that, brought that back to me. I was like, yeah, that's an issue, and it's going to be an even bigger issue as artificial intelligence and machine learning continues. I mean, even to cross the stream, as it were, into the insurance world, apparently they're starting to use it now to make coverage decisions in terms of whether to approve or deny coverage in the health insurance world. So this is a big deal.
Yeah, absolutely. Yeah, and humans were this, notoriously bad at vigilance. Vigilance is hard, and and changing gears, or multitasking is a myth. Changing gears is difficult for us too. So if you're now either asking someone to watch automation do its job, they're going to zone out. And if you're asking them to do something else, but yet jump in when something different is happening, you're kind of going against the way the human brain works in those cases. So,
but the point here is that as risk practitioners, we should have more awareness, and when we are helping our teams build these devices, we should be speaking up, we should be contributing, we should even offer testing. Like maybe we should become test subjects if we have to. Great point, Rafael. Thank you so much.
And once we just identifying and acknowledging these things, like you said, hopefully not finding it late where it involves multiple swear words to deal with it, but identifying them and then finding methodologies to manage that and manage that risk and mitigate that risk. We're not doing it the first time around. We've got lots of things to learn from decades of research in the area. So
wonderful discussion so far. So Ed, thank you for your patience. Please unmute your mic and share what you have in mind. Ed, go ahead. Can you hear me?
Yeah, just getting to the mute button there. Are we okay now? Can you hear me?
Yes, we can hear you fine, Ed. Go ahead.
Okay, fine. Hi, Shannon. How you doing?
I'm doing great, Ed.
Talk with you. I have a kind of a side question. In human factors, URRA is being touted as a great tool to use, and it covers everything from human factors to risk management, but there's nothing discussed about connecting the URRA to the risk management files and everything. So is there anything going on that's going to point out that these two are connected and that what's in the URRA needs to be in the risk management file? Because it looks like it's being promoted as a separate document.
Yeah, I won't dive into my opinions on why I think that's happening, but I will say, I think there's a standard around how you apply human factors for a med device. And that standard is largely based, as is the CDRH guidance, on safety science. So how do we evaluate and identify within safety critical systems the items that we need to focus on and manage accordingly, manage risks for. And so that's kind of the foundation of those. And the URRA, as that's a term that was coined by the FDA, is kind of that look through to identify what are the most critical items. So it does a task analysis. It almost looks a little bit like an FMEA from a use perspective. And it talks about what failure modes or use errors can happen, and then what harms could result from that. Okay, so it doesn't have probability. It's just looking at what are the most critical things, or trying to identify what are the most critical things based on what could happen. And so it's a little bit different than a standard FMEA. And it's a little bit different than, say, your standard risk assessment that you might do for a device failure rather than a use failure. So I think the two purposes of it, though, is one, it needs to drive your human factors work. And the other purpose for it is to inform your risk. And I think sometimes it can be a challenge when people try to use it for both without acknowledging that it's needed for two different reasons. Right. It's needed to go drive your human factors activities, which then come back and help you inform your risk. And so thinking of it as an interwoven process, and that document, specifically the URRA, has multiple audiences, right? It drives the human factors work. It informs the risk from the use risk perspective. And it also creates a regulatory body of evidence for safety around use, which kind of bridges a little bit to clinical data. If I have clinical data, now I'm saying, okay, but when I put it in actual users' hands, they're still using it the same way they did in clinical, or still able to, right? And so it's has a lot of purposes. And so I think making sure that as that's being designed and built into, I believe it should live in the risk management process, or at least be connected to it. Making sure that that's very deliberate, and that you're making sure that you're addressing all of those and not missing any of those needs.
We have to, right? Because I think, Ed, you can probably say a little bit more about that. There's a traceability requirement in 14971, correct? To all hazards.
Yes. Yep.
Correct. Yeah. And
especially when you're adding AI and software, right?
Yeah.
You need that traceability.
Yep. So it doesn't matter how you do it, right? It doesn't matter how you do it, but you must connect it somehow and show traceability. That's the whole point.
Yep.
Right. Okay. All right, guys, let's keep moving ahead because we have very little time left. Darpan, thanks for waiting patiently. It has been a great conversation, but please go ahead and share what you have in mind.
Hi Naveen. Hi Shannon. So my question is more regards to like the overall residual risk for the device, like AI ML device, how it is accounted for, and the feedback through the human factors. So I'm not sure like how the current AI ML devices are performing in the field. And currently we have a challenges to account for the medical devices, use-related complaints, errors that are always underreported, right? And that's how we calculate the overall residual risk to the device. But like for the AI ML device, how the post-market of use error-related complaints or issues are being accounted in the overall risk management?
No, absolutely. Great question. That is an area that there isn't, unfortunately, a lot of discussion around, but there absolutely should be, around just use error in general in the post-market. But I think, and I may be going off on a tangent here, but I think the important thing is to note that when you're talking about human factors, it's actually similar to software in this way. It's foundationally on risk management, right? It's not like reliability testing where I can go test something to a confidence and probability, interval. It's an area where I'm identifying potential risks, and I'm identifying controls, and I'm reducing them as low as possible, right? And it's just like you identify something that could be a potential use error. Just like if you identify an anomaly in your software, you're going to run it through your disposition process and identify from a risk-based decision what you need to do about it. So it comes down to that. And so when you think about post-market data, you need to have a framework that you collect that data and are then able to tie it back in and understand what does that mean? Does that mean I need to do further risk mitigations to lower it or not? So kind of thinking through it from, I think the software disposition process is a good model, if you're familiar with that, to kind of think about how to deal with some of the use risks.
Okay, excellent point. So Darpan, I think I'll tie it back to exactly what you should be doing in a risk management plan, right? If you are building an AI/ML device, make sure you put a plan in place to gather this type of information that Shannon just talked about. And we are going to see, I believe we are going to see in the open domain, especially from FDA's TPLC database, more information come out in the open domain. So keep an eye on it. It's a very rapidly evolving field. Guys, so we have run out of time. Again, excellent conversation. Shannon, I'm going to give you a couple of minutes to just process your thoughts and, share some key takeaways with us. But in the meantime, guys, a couple of announcements. First, a little bit of a bad news here because LinkedIn seems to have completely changed their live audio platform. Beginning next week, we'll have to actually use a third-party software to stream live into this. So I'm in the process of testing it out. We will still have our event, but I would ask for your patience. We might have some technical glitches. We're going to have a great conversation with my guest, Jack Garvey. We're going to talk about how to draft a good problem statement for CAPA. So this will be a great conversation, but I ask for your patience. There might be some technical glitches and we may not have as engaging a conversation as we have in this forum. But I was pretty upset when I learned about it today that LinkedIn has just stopped the audio events. We have to do it slightly differently. So just stay tuned. I hope you still show up. Let me know if you have any concerns or questions in mind. And if you do want to participate, let me know ahead of time because I will make sure we figure out a way for you to participate in these conversations because to me, that is the most important element of these conversations. So with that, Shannon, the floor is yours. Please share just a couple of key takeaway points with us.
Sure. This has been a great discussion and I would love to keep going. But I think the main takeaway that I've been hearing and as we talked is when you think about AI, ML, automation, right? Technology. And you're thinking about use-related hazards, make sure you're capturing and use the guidance documents that are out there and they point to other reference resources for understanding those potential hazards that come with what I'm calling automation, right? And capturing those in your risk file, you may not have a clear answer for how to manage those, but capturing those and identifying those is one, going to give you the best opportunity for design, but also to the last question around post-market, having those in there provide the hook for you to think about, okay, one, how am I going to evaluate this as I design? Is that my clinical study or some other evaluation if I understand complacency, right?
Yeah.
But then if that's also a risk then in post-market, then that's going to give me a chance to think about how do I want to monitor for that in post-market? Is there a way I can do that, with my existing pool of customers, or is that something I need to rely on literature reviews for? Mm-hmm. So what am I looking for, right? So capturing that as early as you can in your risk analysis or advocating for thinking about use-related risks for your AI devices early is just going to give you a better chance to build that in and be able to capture those more quickly when they happen.
Wonderful. Thank you so much, Shannon. Guys, how are you feeling? I think this was a great conversation. Please show your reactions using the emoji icons. I would love to hear your feedback. And again, you can also reach out to me one-on-one to share your feedback and any suggestions for future sessions. It's very important for me to make sure that you are getting a lot of value out of these conversations. You give us 30 minutes of your time and everyone is busy. And we want to make sure that all of us are gaining value out of these discussions. So you are a very, very important part of these conversations. They are for all of us, not just for me or someone else. It's for our whole community. I hope you will keep on participating, keep on engaging, and keep on reaching out to me with your feedback and comments. Thank you again, everybody, for joining. Thanks, Shannon, for being so generous with your time and sharing your insights. I wish you guys a very good weekend ahead, and we will connect once again next week. Take care, everyone. Bye-bye.
Excellent to talk to you always. Thank you.